Hello everyone, welcome to the class once again. I hope you're all doing good and in the best of your health. So after learning all the concepts in this chapter, mechanical properties of fluids, I believe that you'll be ready to solve questions. I believe that most of you all would have also practiced question after each of the classes, and I believe you'll be thorough with the formula that we have discussed in this chapter. So in this class, we'll be discussing question based upon NEET pattern exercise, that is question that would be probably asked in your NEET examination. We'll practice questions that are of the kind that would be put up in your NEET examination. And let me tell you, your NEET examination question asked are of single choice. That is, each question will be having one answer as the correct answer and 3 options will be incorrect. If you choose the correct answer, you will be awarded with plus 4 marks. If you choose the incorrect answer, you will be suffering with minus 1 marks. So you need to be wise, you need to be thorough with the concepts so that you can answer them correctly. Level of difficulty can be easy, can be moderate, a bit quite higher than moderate, you can think about it, and you can expect question can be of any kind in your NEET examination, and question will be asked from this chapter. It's a very important chapter. Question will be framed in this chapter, and as per the past data that we know, questions are regularly each year has been raised in this chapter. Let's go ahead with the first question of the day. Let's start it. We have the first question: the wettability of a surface by a liquid depends primarily on. This question has been asked in one of your previous NEET examination, so it's a very important question. And if you remember the theory that we have discussed in the class, it says that wettability, it means the adhesive force between the surface and the liquid should be more than the cohesive force. And that depends upon, or first of all, that depends on viscosity? No. That depends on surface tension? No. Density? No. D, angle of contact between the surface and the liquid? Yes. How can you think of that? We all know that I have told you, if the adhesive force is more than the cohesive force, the angle of contact will be acute, it will be less than 90 degree. And if the cohesive force is more than adhesive force, then the angle of contact will be obtuse. So let me write down those 2 points about adhesive force and cohesive force. So first thing, if adhesive force is greater than cohesive force, we have angle of contact to be, adhesive force is greater than cohesive force, we have angle of contact will be acute. So theta contact will be acute, that it will be between 0 to 90 degree. Second, if adhesive force is less than cohesive force, we have the angle of contact will be obtuse, that is, it will lie between 90 to 180. It lies between 90 to 180. This is what we have learned. In this case, angle of contact will lie between 0 to pi by 2. This range gives us the value from where the angle of contact will be lying, what will be its range. Now after this, we can clearly make out that if adhesive force is more, it's going to wet the surface, hence angle of contact will give you the idea of wettability of a surface by a liquid. So the right answer will be option number D, angle of contact. Just now I told you, I can believe that you have understood the logic behind this, angle of contact between the surface and the liquid. Let's go ahead with the next question of the class. Question number 2. A certain number of spherical drops of a liquid of radius r coalesce to form a single drop of radius capital R. You see a certain number, you have n number of drops of liquid of radius r, they form a single drop of radius capital R, and its volume is given as V. If T is the surface tension of the liquid, then energy this much is released, energy equals to this much is absorbed, energy equals to this much is released, and energy is neither released nor absorbed. In the case of a drop, I have told you how to find out the surface energy. If you remember, the surface energy is given as the surface area multiplied with the surface tension. Here I am using T for surface tension, not S, because in this example, in this question, we have provided that the T is the surface tension. So in this way we are using. Let us say let n number of drops coalesce. let us say n number of drops coalesce to form one larger drop of radius capital R and volume V. So initial surface energy will be given as N into initial surface area, let's say it's AI multiplied with T. So initial small drops are having the radius small r, and the larger drop which they make after getting coalesce, that is its radius is capital R. So we can write this as N into area initial will be 4 pi r square multiplied with T. First thing we obtained in this way, and leave it in this way, not a problem, you can leave in this way. Now final potential energy, final surface energy after coalescing, one drop is made of surface area 4 pi r square multiplied with T. The problem in these two equations will be N. We all know that the larger drop is formed due to coalescing of smaller drops. You can say that N into 4 by 3 pi r cube will be equal to 4 by 3 pi r cube. We can comment in this way. So finally you see here this term will be cancelled out. You will be having N equals to r cube divided by r cube. So we got the first thing, N value. Substitute here the value of N here, you will be getting initial surface energy is N into 4 pi r square T. So you will be having initial potential energy as r cube by r cube, and here you are having 4 pi r square, 4 pi r square into T. This is the term that you are having, 4 pi r square into T. Now you see here some terms will be cancelled out, you will be left with some terms. Here you will be getting 4 pi r cube and divided by r multiplied with T. If we divide this entire equation by 3 and multiply with 3, we will be having 4 by 3 pi r cube. 4 by 3 pi r cube will give you the total volume of the larger drop. So we can write this as 3 Vt by small r. This is the value of initial potential energy, 3 Vt by small r. Next thing, if we talk about the final potential energy that we have evaluated, that has been 4 pi r square T. 4 pi r square T. If I am just, what I am going to do, I am going to change the way it looks to us, 4 pi r square into T. Here, if we divide it by 3 and multiply by 3, not a problem, and also we are going to divide by r and multiply by r. So you will be having 4 by 3, r and pi also is there, so I am just adding pi, I have missed that, 4 by 3 into pi into 3 r square T r by r. So from here you see 4 by 3 pi r cube will give you volume, so this will be 3 Vt by r. This is the final volume of potential energy. Final potential energy is 3 Vt by r, initial potential energy is, just to see here, it's 3 Vt by small r. Can you see small r is lesser, smaller drop, they are in less, they are in denominator. So initial potential energy will be higher, final potential energy will be smaller, this is larger, r is larger, so UF will be smaller. That means initial potential energy is higher, final potential energy is smaller, so energy will be released, and the amount of energy released will be, just do Ui minus Uf, you will be having 3 Vt 1 upon small r minus 1 upon capital R, and energy is released. Energy is released, that is what we can see here. Let's see, energy equal to 4 Vt 1 upon r minus 1 upon r is released, no. Energy equal to 3 Vt 1 upon r plus 1 upon r is absorbed, no. Energy equal to 3 Vt 1 upon r minus 1 upon r is released. That's the right answer. I hope that you have understood how to solve this. You should accordingly move ahead stepwise and you will reach to the right result. It's a good question, and this question has been asked in your previous examination. So if you know the method, if you have practiced question on this, you can very easily solve such questions. Next question 3. Three liquids of densities rho 1, rho 2 and rho 3 with rho 1 greater than rho 2 greater than rho 3. This is given. Having the same value of surface tension T, rise to the same height in the three identical capillaries. The angles of contact theta 1, theta 2 and theta 3 obey. This. We have to compare angle of contact. For this question, let me talk about how the height is related to angle of contact. It's 2s cos theta upon r rho g. Different densities. So densities will be variable for each. Having the same value of surface tension T. So surface tension S I have used here. Let's use T, that will be better as per the given question. 2T cos theta upon r rho g. Rise to the same height. So H is also same. In the three identical capillaries, the angle of contact theta 1 and theta 2 and theta 3 obey. They have the same height. So if we use H1 in this way, now this we can write, this will come out to be cos theta 1 upon rho 1. Radius is also same, g is also same. So I am removing it. This is the equation which we can write. Now it's given that rho 1 is greater than rho 2 is greater than rho 3. So from this equation we can make out if rho 1 is greater than rho 2 is greater than rho 3, we can make out cos theta 1 this will be applicable. We all know that if cos theta 1 is greater with respect to some other cosine of angle, then this angle will be smaller. So you can compare, if you are good enough in your trigonometry portion, you can say that theta 3 will be largest, so cos theta will be smallest in this case. Theta 1, theta 3 is largest, then theta 2, then theta 1. And in this case, since the liquid is rising, the angle of contact has to be less than 90 degree, and I have discussed that. It will be less than 90 degree. So theta 3 is largest, you see A, theta 3 is smallest is shown here, that's wrong. Theta 3 is largest, yes, this is applying, and it's between 0 to pi by 2, yes, this is correct. Here theta 3 is largest, but its angle is lying between pi by 2 to pi, so incorrect. Here theta 3 is smallest, so again incorrect. So only option that is valid, that's option number B. Clear to you all, I believe that. Let's go ahead with the next question of the day. We have question number 4. A water film is made between two straight parallel wires of length 10 cm separated by 5 mm from each other. If the distance between the wires is increased by 2 mm, how much work will be done? Surface tension for water is 72 Newton per centimeter, A 288 ergs, B 72 ergs, C 144 ergs and D 216 ergs. Now see here, surface tension, we are talking about surface energy, how much work will be done? Work done will be equal to increase in surface energy. Work done will be equal to increase in surface energy. So surface energy increase will be equal to increase in surface area multiply by, so delta A increase in surface area multiply by surface tension T. Now increase surface area, since the wire frame is increased, the density is increased, there will be two area films on the wire. You can see this. This is the wire film. If I show you, if this is the liquid film, there will be two areas, one upper, one lower. So what you do? 2 into increase in area, let me write here delta A in 1 into T. If you are confused with this, I am also multiplying 2 here so that you don't get confused. 2, you see the length is given as 10 mm, sorry 10 centimeter, wire of length 10 centimeter. separated by 5 mm from each other if the distance between the wires is increased by 2 mm. So let me write here, this is 10 centimeter, so 10, and let us, because the answer is given in ergs, so you can keep the unit in centimeter. 10 centimeter multiplied with increase we need to find out, so 2 into 10 to power minus 1, and the value of surface tension that is given as 72 dyne per centimeter. So let us put here 72 dyne per centimeter. All units are in CJ system, so its answer will be in, quite obvious that will be in CJ system. So here if you solve it, 2 into 4, 4 into 7 to 144, and you will get 144 ergs as the answer, this and this will be cancelled out. Sorry, I did 144, it will be 288, I am sorry, it will be 288. 2 into 4, 4 into 72, that's 288, that's not 144. Let's go at option number 8, 288 ergs, that's the right answer, rest all are incorrect. Clearly, we have done 2 questions based upon surface energy. You can understand that surface energy question can be raised in your NEET examination. Be thorough with this chapter, question will be asked in this chapter. Next question of the class, we have 5th one. A ball of mass m and radius r is released in a viscous liquid. The value of its terminal velocity is proportional to A 1 by r, B m by r, C under root m by r, and D m only. Its mass and radius we have to compare on which the terminal velocity is dependent. We all know that terminal velocity 2 by 9 eta 2r square rho minus sigma g. This is what that we know about terminal velocity. It's proportional to radius. Rho is the density of the metal or the object with which is moving. Sigma is the density of the liquid in which it is moving. G is the extent due to gravity, and 9 and eta is the coefficient of viscosity. This formula we have derived for terminal velocity. I hope that you are remembering this. Now velocity we can write it's proportional to r square, and here you see there's also rho given. Now what is rho? Rho is mass per unit volume, and volume will be 4 by 3 pi r cube. We can write in this way. So we can write rho is proportional to m upon r cube. So if I write here for velocity now, velocity proportional to r square and rho is proportional to, you can do here m upon r cube. M upon r cube we got this, and finally you substitute here m upon r cube. So you will be getting volume is proportional to velocity is proportional to m by r. So before commenting on the answer, let me get to with more detail in this. So what you first take note of this, I will talk more upon this also, take note of this. So one thing that you can make out, if you only write this formula, if you write only this formula, you will be confused that how to proceed. R square is there, then rho is there, how to proceed. It will be difficult for you, and you will be thinking that which option to choose. M is not coming, so you will be thinking that what to choose. Some of you may get confused and you will choosing 1 by r. That will be a mistake. And B m by r, that is the answer that we have reached, that is the right answer. If you are not proceeding in this way, you may be confused that what option to choose, and sometimes you can get confused. You can also mark only m, because you must be thinking that m will come here because rho is somewhere proportional to m, and you may mark here m, but this is also incorrect, this is also incorrect, only option is m by r. I hope that you have understood what kind of questions do come in this chapter. Capillarity will be important, then Bernoulli's equation will be used, sometimes equation of continuity will be used. If you have attended all the lectures, if you have seen all the lectures, the entire syllabus has been covered. So the questions cannot be framed out of the context that we have discussed in our regular classes. All this set of questions I am discussing, here I have discussed first 5 questions, the next 5 will be taken care in the next class. But let me tell you, it will be of great help to you all in solving the unsolved question and in your preparation. And the second advice that I am regularly saying you, after each of the classes, do practice question. That's advisable. I hope that you are also solving question on your own. Be thorough with the basic formula, this velocity that we have discussed here. the terminal velocity. People do not remember this formula, and you start deriving on the day of examination, that will consume your 2 to 3 minutes time. And why to give time on derivation if you can remember such simple formula? Do remember the velocity of efflux formula also. Do remember this terminal velocity formula. Do remember the height of the liquid column in the capillary tube, that's h is equal to 2s cos theta upon r rho g. All this will be of great help to you all. So I have this first set of 5 questions in this class. I will be discussing some more better questions in the next section of this chapter, and I believe that you are enjoying learning with me physics, because I am enjoying teaching you all physics. Thank you everyone. I'll meet you in the next class. Wish you all the very best.